Hello class, let's take a look at section 1.5 in your textbook. I will be covering most of 1.5, but there will be an additional video for next week's homework on the last two topics of 1.5. All right, so the graph of a function, again, I would recommend that you read this. I'm going to skim through it. Example 1, use the graph at the left to find the domain of f, and then f of -1, f of 2, and the range of f. So let's take a look at this. Whenever you see an open circle like that, that means that this point, the point 5, 2, 5 would not be included in the domain. So the domain, remember, is the x values. So we start with an x at -1, and that is included, and we go to 5, but 5 is not included. So I want to show you something called interval notation. This is interval notation. How do we write -1 to 5? -1 is included, so we use a squared off edge, and 5 is not included, so we use an open. And this is the interval from -1 to 5. So this is the domain of the function. Okay, now let's take a look at this. And our function goes from a low point of, remember the range is the y values, has a low point of -3, and it has a high point of +3. And notice that those are points that are included. So we could say the range is from -3 to 3. Now this interval notation is interesting. How do we know that we're talking about an interval, or how do we know if we were somehow talking about the coordinates of a point? It's just how it's used in context. So a domain and a range can be represented by this interval notation, and as you read through here, you will see that that's why it's closed and open. What is f of -1? Well, we go to an x of -1 and we see what is the value of that function? It's 1. So f of -1 is 1. What about f of 2? So let's go to 2. F of 2 would be -3. So from the graph, we can answer these questions. We got the range. All right, let's flip the page to example 2. I already did talk about the vertical line test for functions. When you've got a graph, super easy. Is this a function? Bing, bang, it hit the graph twice. So that would be not a function. Here with this polynomial, polynomials have nice smooth roller coaster curves. No matter where we would draw a vertical line, it's only going to hit the graph once. Don't look at the axes here. Don't look at that. I don't care how many times it hits that. It only hits graph once for any vertical line I draw. So that would be yes, this is a function. Well, what about this? Is this a function? Yes, indeed it is. And then I will let you read here. It is a function because it passes the vertical line. This is a piecewise function. Remember the piecewise ones we looked at before? So it's a certain expression for all x's less than or equal to 0, and another expression for all x's greater than or equal to 2. This function is not defined for these x's. I don't care. So even though it doesn't hit anything here, the thing is it can't hit twice. So not a function, yes and yes. All right, the zeros of a function, we already talked about this. How do we find the zeros of a function? If it's a quadratic, to find the zeros, we either have to factor or use the quadratic formula. And there are 3 examples here. These are pretty simple algebraically, so I will let you look at those. Here's one thing to know. When you have a fraction, where's a fraction equal to 0? A fraction is equal to 0 when the numerator is equal to 0. So do you see how they just dropped off that denominator? And they found t, when t equals 3 over 2, this numerator is equal to 0. Now, remember how we're bothered by the domain of this? T cannot be a negative 5. So if you solve this and you got a t equals negative 5, then this would have no zeros, because that when the denominator is 0, that cannot be a value of t. Hope I'm not going too fast. Increasing and decreasing functions, pretty self-explanatory. We always look at a graph from left to right, just like you were reading. So as we're reading this graph from left to right, this function is decreasing. Now it's constant, and then here it's increasing. So increasing, decreasing, and constant functions. What is this graph doing? Notice that we don't have a dot here. So where does this function end? The answer is it doesn't end. It's going down, 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 down. X is going to negative infinity. It's going forever, and this function is coming up from some unknown value, right? We're assuming there's not another little squiggle over here, or it would have showed us. So it's only showing us what's important here. So what is the domain of this function? The domain of this function is all real numbers. So that would be from negative infinity to infinity. Notice that infinities are always open. All right, what would be the range of this function? Negative infinity to positive infinity. We assume that it's going up, up, up forever. All right, let me read the directions here. Where is each function increasing? Well, remember, we go from left to right. So if you were a little bug and you were riding this roller coaster, you're going up, up, up. That's increasing. So from, remember, negative infinity to, where's our x value? -1. And it's a hard dot, right? So the function is increasing on the interval from negative infinity to -1. Okay, so why is this open at -1? Because at -1, it is neither increasing nor decreasing. Does that make sense? It's kind of just hovering. Like if you're on a roller coaster, you're hovering right at the top. Okay, so that's why it's an open interval there. Now you're going down, so now you're decreasing, 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 decreasing until you get to 1. So now it's increasing on the interval. It's talking about this one. It's increasing on the interval from -1 to +1. I'm sorry, decreasing, you're going down, down, down. So increase, decrease. I'm making this more complicated than it should be. And then increasing again from 1 to positive infinity. This function, what are you doing? Increasing, constant, decreasing. This function, increasing the whole way, always increasing. You can have functions that are always increasing or always decreasing. Go ahead and read this. All right, what's a relative min and a relative max? Well, if we looked at this function, a relative max would be like if you were playing King of the Hill and you're higher than all the points around you. Now, this function goes up forever, right? So it has no absolute maximum, but it has a relative maximum here. And then do you see how this would be a relative min? Because as far as all the points in the immediate vicinity, that is the lowest point. Okay, so here's some definitions of relative min and max. You know, this might be harder to understand, but if you have a nice roller coaster function, all the lows are relative minima. That's plural for minimum. And all of the highs are relative maxima. So you can have many of these points as you go along. All right, so now what I'd like you to do is grab your graphing calculator. So pause this video if you don't have it with you. We will be using this quite a bit. Part of this class is to learn how to use this graphing calculator. And I'm going to do example 5. And example 5 is use a graphing utility to approximate the relative minima of the function. Sorry for all this confusion here. So this is how we do it. Turn your calculator on, go to y equal. Got something in there I need to clear out. And then we have 3x squared. So I'm going to do 3x, use the caret, squared, minus 4x. Do you see how my cursor is up in the exponent, so I have to cursor over, minus 4x minus 2. Now, I want to look at my window. The normal window is from -10 to 10, and I have that. So I'm going to graph. Okay, so this is a degree 2, which I know is a parabola. So I know that there aren't any other humps going on over here, right? All right, so do I have a relative max? Nope, because we know this parabola just goes up, up, up. But I do have a relative min. So I want to show you how to do that. We're going to use the calculate. So whenever you go up there, you have to do second calculate. And I want to calculate the minimum. So use your cursor to go down to minimum, enter. And you see where the little cursor is here? And they say, hey, am I on the left of the min? And I'm going to go, yep. And then it says, take me over to the right side. So I'm going to cursor over past the little bump. And it doesn't matter. I could stop there. I could stop there. It doesn't matter. Enter. I'm not sure why it always says guess, but it does. But we just press enter. And then it will tell us the minimum occurs when x is 0.6666. Do you know, I hope you recognize that number as 2/3. And y is a -3.333, -3 1/3. And we found the relative minimum of that function. I also want to show you how to find the zeros of the function. So let's use this same function. I'm going to calculate the 0. So that means to go down, sorry about the glare, one time to the 0. And this function has 2 zeros in it. Here's a 0. Remember, the 0 is where it crosses the x-axis, and here's a 0. So it says go to the left side of the 0. So what's important here is you only do right and left. Never go up or down or you'll hop off your curve. So I'm on the left side of this 0. So I'm going to enter. And then it says take me over to the right side of that 0. Enter. Yes. No, thank you. And there's the 0. -0.3874259. If you were studying for the AP Calc exam, you would round that off to 3 decimal places. So the 0 is at approximately -0.387. Whoops. So now we have the other 0. So let's calculate the other 0. Enter. I want to go over here, right? So I want to be on the left side of that 0. I got to get a little closer to it because, right, my calculator can't read my mind. I need to narrow it down to this side. Enter. Couple scooches to get on the right side of that 0. And there's the other 0. Do you see what that would round off to? 3 decimal places. Okay, if you're not getting those same numbers, we should. So stop and try and do that again on your own. We're finding the zeros of the function. So now you should know how to calculate the max, the min, and the zeros of the function. All right, let's put that away. Let's look at I think that's it for today. Okay. Oh, one more note. What if you were going to find the max and the min? You wanted to graph this function, x squared minus 1 over 2x plus 10. I am going to grab my calculator one more time. I want to make sure that you know that we need to use parentheses. So that equation was x squared minus 1. So I'm going to do x caret squared, cursor over, minus 1, parentheses, divided by, and then it was 2x plus 10 on the bottom. So parentheses again, 2x plus 10. All right, and then we can graph this. Interesting graph, right? All right, so the important part there is make sure if you're putting in a fractional or rational function to use parentheses. All right, that's it for this week.